Imagine a telescope so powerful it can peer back over 13 billion years into the past, almost to the very birth of the universe. A telescope that doesn't just capture light, it reveals the mysteries of the cosmos in ways we've only dreamed of. Welcome to the James Webb Space Telescope, humanity's boldest step in understanding the universe. Launched in December 2021, JWST is the successor to the Hubble Space Telescope, but with capabilities far beyond anything we've ever seen. In the next few minutes, we'll explore the groundbreaking technology behind this space marvel, its first major discoveries, and how it's changing the way we think about the cosmos. So, what exactly is the James Webb Space Telescope? JWST is a large infrared space telescope designed to explore the universe in a whole new way. It's the largest space telescope ever built, about the size of a tennis court, and it operates mainly in the infrared spectrum. That means it can see through cosmic dust clouds and peer into the heart of distant galaxies, something visible light telescopes can't do. The telescope has a 6.5-meter-wide mirror made up of 18 gold-coated hexagonal segments. It was carefully designed to capture more light and in turn provide sharper and more detailed images than any previous telescope. JWST's mirror is so large it had to be folded to fit inside the rocket during launch, then unfolded once it reached space, a feat of engineering that amazed even the most seasoned scientists. But how does it work? Well, JWST's primary mission is to capture infrared light. While visible light can't reach us through thick cosmic dust, infrared light passes through it, revealing hidden stars, galaxies, and even exoplanets that might otherwise remain out of view. JWST's infrared vision allows it to look at the earliest stages of star formation, the formation of planetary systems, and even trace the history of galaxies over billions of years. One of its key tools is the near-infrared camera, NIRCam, which can see the first stars and galaxies that formed just after the Big Bang. Another important tool is the mid-infrared instrument, MIRI, which allows it to capture cooler objects like distant exoplanets and asteroids, as well as cosmic phenomena that emit faint infrared radiation. And here's where it gets even more exciting. In just its first few months of operation, JWST has already made several jaw-dropping discoveries. In one of its first images, it revealed the deepest infrared view of the universe ever captured, a stunning glimpse of galaxies that formed just 300 million years after the Big Bang. These images are so clear and detailed that they'll help astronomers study galaxy formation and evolution in ways we could never have imagined before. One of JWST's key achievements was the discovery of spectacularly distant exoplanets. In one case, it observed the atmosphere of a distant exoplanet in exquisite detail, providing valuable information about its composition, temperature, and even signs of potential habitability. This discovery could bring us one step closer to finding life beyond Earth. JWST has also been studying the formation of stars and planetary systems, focusing on regions like the Orion Nebula, where new stars are born. These observations allow scientists to look at the processes that give birth to planets, potentially similar to our own. But perhaps the most fascinating mission of JWST is its quest to answer one of humanity's oldest questions: are we alone in the universe? By studying the atmospheres of exoplanets, JWST will be able to detect the presence of key chemical compounds such as water vapor, carbon dioxide, and methane, substances that are associated with life as we know it. It may even help identify biosignatures, subtle clues in the atmosphere that suggest the potential for life. Imagine a future where JWST finds signs of microbial life on an exoplanet orbiting a distant star. the implications for science and humanity would be nothing short of revolutionary. But with all these groundbreaking discoveries, there's a reminder that space exploration is never easy. The journey to launch JWST was long and full of challenges. It took over 20 years of planning, design, and construction before the telescope was finally ready for launch. And even after it left Earth, there were still major hurdles. JWST had to travel 1,000,000 miles from Earth to its destination at Lagrange Point 2, L2, where it orbits the Sun. Along the way, engineers had to ensure that it deployed successfully in space, from unfolding its giant mirror to activating its instruments. Every step was crucial, and every move was a potential risk. But against all odds, JWST made it, and now it's unlocking the secrets of the universe, pushing the limits of human knowledge. So, what's next for the James Webb Space Telescope? The future is incredibly bright. Over the next few years, JWST will continue to capture groundbreaking images and data, helping scientists answer questions about the origins of the universe, the possibility of life elsewhere, and the nature of dark matter and dark energy. In many ways, we are just beginning to scratch the surface of what JWST can do. As it reveals deeper and more distant parts of the universe, it will continue to inspire future generations of scientists, engineers, and dreamers. It's not just a telescope. It's our window into the cosmos, a testament to human curiosity and the unyielding desire to explore the unknown. Thank you for joining me in this exploration of the James Webb Space Telescope. If you enjoyed this video, don't forget to like, comment, and subscribe for more on the latest breakthroughs in space exploration. And remember, the universe is vast, and there's always more to discover.